This is Dr. Emmanuel, and I want us to do a revision on the limbic system. So what is the limbic system? System is a collection of structures, isn't it? So the limbic system is a collection of structures within the brain, within the cerebral hemisphere, that play important roles in homeostasis, memory, emotions, sleep, and some other functions of the body. Okay, hormonal and we can broadly say hormonal functions, homeostasis, and emotional control of the body. On this first image, we can see some prominent parts of the limbic system: the hypothalamus, so the anterior nuclei of the thalamus, the amygdala, and the hippocampus. And on this image, we can see that the hypothalamus plays a vital role in homeostasis. Homeostasis simply means regulation of the physiological functions of the body. Thalamus plays an important role in relaying of information. So relaying means you receive information from one part of the brain or from one part of the central nervous system, and you process that information and discharge further information either to the same part of the brain where you got the information or to some other part of the brain. So the thalamus plays that central role of information relay. We've got the amygdala right there. And amygdala plays an important role in emotions, control of your emotions, control of your appetite, control of your sleep. So the amygdala is very vital, and hippocampus plays an important role in memory processing, memory conversion, formation of long-term memory. And I'll just need to say that this limbic system plays, it works in tandem with the prefrontal cortex. So the prefrontal cortex is right here, somewhere here, in the superior, the superior frontal gyrus and the middle frontal gyrus. So the prefrontal cortex works closely with the limbic system. So what are the functions of this limbic system? Emotional regulation, decision-making, sleep cycle regulation, regulation of behavior. So how a person behaves is strongly tied to the functionality of their limbic system, as well as the prefrontal cortex or the frontal lobe. The long-term memory, so the hypothalamus and the mammillary bodies are responsible for the formation of memory. Activation of the immune system, hormonal regulation, so the amygdala plays a role in hormonal regulation, regulation of your appetites, the amygdala, mood control or mood regulation, homeostasis, the hypothalamus. So the prefrontal cortex works closely with the limbic system, forming the frontal limbic communication. If someone has a problem with their frontal lobe, which is frontal lobe syndrome, maybe from your frontal lobe, from a frontal lobe tumor or ischemic stroke, they're likely to have, similar functions as someone who has a problem with their limbic system. Composition of the limbic system. Limbic system is composed of several parts of the brain. We have the cingulate gyrus. So looking at the medial surface of the cerebral hemisphere, just above the corpus callosum, we have the cingulate gyrus. Okay, so that's the cingulate gyrus. It's quite extensive, spanning from the anterior, spanning from the head around just superior to the head of the corpus callosum, right back. Okay, and then it continues with the parahippocampal gyrus. Okay, and that's the amygdala. So the cingulate gyrus, we have the subcallosal area. That is the corpus callosum. Okay, and just beneath the corpus callosum is the subcallosal area. We've got the fornix. Okay, the fornix is below the corpus callosum. Okay, remember when we looked at the structure, of the cerebral hemisphere, we came across some of the structures, the fornix. The mammillary bodies, got the mammillary body there. So that's the fornix, proximal part of the fornix, just around the fimbriae of the fornix or the columns. We have around the columns, proximal to the columns of the fornix, we have the mammillary body. So right and left mammillary bodies, they are both of them We've got the hippocampus, we've got the parahippocampal gyrus, also called the hippocampal gyrus. We've got the amygdala, we've got the hypothalamus, and we've got the anterior thalamic nuclei. Same image. And so the previous images were just extracted from Google, whereas this image is extracted from the Human Atlas, the Atlas of Human Anatomy by Frank Netters. So this is the medial surface of the cerebral hemisphere of the brain as a whole. We can see as the corpus callosum, and superior to the corpus callosum on this medial surface is our cingulate gyrus right there, okay? So that's our cingulate gyrus, okay? It's inferior to the medial frontal gyrus. So cingulate gyrus, and right there is our subcallosal area, okay? This is the corpus callosum. So just below the head of the corpus callosum is our subcallosal area, okay? Right there. It's part of the limbic system. We've got the thalamus, and below the thalamus, we've got the hypothalamus there. The hypothalamus is somewhere, just below the thalamus is the hypothalamus. And you can see the hypothalamic sulcus, which is the sulcus between the thalamus and the hypothalamus. So what else can we see on this image? Got the mammillary body there, okay? Got one mammillary body, the right mammillary body. And still on the medial, so this shows both the medial and the inferior surfaces of the cerebral hemisphere. The same thing, we can see the cingulate gyrus, we can see the subcallosal area, we can see the mammillary body, we can see the fornix, okay, the columns of the fornix, we can see the body of the fornix, we can see the cross, right and left crura, all right. We can see the parahippocampal gyrus, which is otherwise called the hippocampal gyrus there, okay. That's the cingulate body, that is the posterior part of the cingulate gyrus, posterior part of the cingulate gyrus there. Inferior surface of the cerebral hemisphere, same thing, we can see the right and left, so the pair of mammillary bodies, okay, just behind the pituitary gland, parahippocampal gyrus. So having had an understanding of the functions of the limbic system, it to be easy for us to understand what could happen, what could go wrong if someone has disorders of their limbic system. So they can have disinhibited behavior, behaving in aberrant ways, maybe sexually disinhibited, having excess anger expressions, excessive anger, just talking when they shouldn't be talking. And disorders of the prefrontal cortex also, can give you most of these problems. So mood disorders, depression, anxiety, bipolar disorders also linked with disorders of the prefrontal cortex. Sleep disorders, insomnia, hypersomnia, like in narcolepsy. Okay, cognitive problems, dementia have been, from hippocampal damage or hippocampal injuries, which can be from stroke, hippocampal tumors, intrinsic or external tumors compressing the hippocampal area, can give you some of these. Excessive anger, we said, hypersexuality in Clover-Bussey syndrome from amygdala damage, anxiety, excessive, anxiousness, amygdala injury, appetite dysregulation, thalamic injury. Okay, and then eating disorders. So a patient can have emotional eating disorder, bulimia nervosa, anorexia nervosa. There's a very strong tie or connection between the limbic system and the prefrontal cortex. Okay, so most of these problems can be attributed to both parts of the brain. So by way of summary, the components of the limbic system include the cingulate gyrus, the subcallosal area, the parahippocampal gyrus, the hippocampus, the amygdala, the fornix, okay, yeah, and the mammillary bodies, right and left mammillary bodies. So we've come to the end of this revision of the limbic system. If you think it's been helpful, kindly like this video, subscribe to my channel, and share with your friends. Thank you.